Okay, so today we're going to be looking at, we've been working with exponents, and now we'll get into actually graphing and finding out how we can identify exponential functions. So up at the top, kind of the formula that we're going to use today, just go ahead and circle that y is equal to ab to the x power. Our x is going to be our exponent. That's going to be what we're plugging numbers into. And so the first thing we're going to do is just learn about identifying exponential or linear functions. So with a linear function, the same number is added over and over again. And with both of these, we need to make sure that our x is increasing by the same amount. So if it's linear, same number is going to be added over and over again. With an exponential function, the same number is going to be multiplied. So when we look at an xy table, like in the first two problems, again, the first thing I want to notice is that going up here, my x's are going up by the same amount. And so I can look at my y's, and usually the way, sometimes you can see it really quick, the way that I usually do this is I want to figure out, if I figure out that it's not linear, then I can look at it being exponential. So from going from -1 to -3, that would be subtracting 2. -3 to -9, that's subtracting 6, sorry. And then 9 to 27, be what, 18? Yeah. This would be minus 18. So I can see that it's not going to be linear because it's not the same number added over and over again. So instead, look for it to be multiplied. So to go from -1 to -3, I can multiply by +3. To go from -3 to -9, I can multiply it by 3. And from -9 to -27, I can multiply it by 3. So as soon as I see that multiplication by the same number over and over again, I know that it's exponential. With the second one, again, I want to start with figuring out whether it's linear or not. My x's are going up by the same amount each time. So to go from -1 to 1, I go +2, 1 to 3, +2, 3 to 5, +2. Again, the same number being added over and over again is going to be a linear function. If I'm just given a equation, then it becomes pretty easy. If I see that my x is a regular number, not an exponent, I know that it's not going to be exponential. This is going to look like, if you remember from first chapter, y is equal to mx plus b, where 3 is my slope, and then the +0 would be my y-intercept, so this is going to be a linear function. Again, since the x is a regular x, fits the form y equals mx plus b, that's going to be linear. With the second one, again, as soon as I see that x in my exponent, right there, I can see that it's going to be exponential. It's going to look like y is equal to ab to the x, which is the formula we had at the top of our notes. And so this one's going to be an exponential. There you go. And so when we move on to graph these, we're going to graph it just like we always do, plug in numbers into our graphing calculator. So input-output table, we're always going to use -2 to +2 unless I tell you differently. So with these, again, I'm going to make my xy table. Always go -2, -1, 0, 1, and 2. And then the trick is just being able to plug it in. So let me jump over to my graphing calculator. Okay, so on my graphing calculator, again, I hit the y equals button to get to my table, or to get to my input. I'm going to go 0.5 times 3 to the x power, and then go to my table. Again, I'm going to use -2 through +2. Same thing over here. I don't think it actually puts it in any differently. 0.5 times 3 to the x power. And this one, it'll put your x actually up into your exponent, but that shouldn't change any of the things that we're doing here. So it should all kind of be the same. So I should get my same table here. So again, when I go back to my graph, for the first one, again, my xy table, -2 through +2. So my negative 2, I get 0.055, so I'm going to round to the nearest tenth, so it'll be 0.1. Negative 1, I get 0.2. 0, I get 0.5. 1, I get 1.5, and 2, I get 4.5. And so when I plot each of those points, negative 2.1, again, is just super close to the x-axis. Negative 1.2 is, again, still really close to the x-axis. 0, 1/2 is halfway in between. 1, 1.5 is right 1 up 1.5, and then 2 up 1, 2, 3, 4.5. And so what I get here is I get a graph looking like this. What we do need to make sure is that our graph will never cross the x-axis on these. And so that is something that I will actually mark off points if you ever have it cross. It'll never cross the x-axis. The fancy word for it is an asymptote. It's going to be a horizontal line or vertical line that it never crosses. So these graphs will never cross our x-axis one way or the other. With the other one, again, same thing. I do my x and y. Go from negative 2, negative 1, 0, 1, and 2. And if you go back to your calculator, it's actually pretty easy to insert. So you're just going to put a negative in front, and then the same thing. And what's going to happen is it's going to give us the same numbers, just all negative. So negative 0.1, negative 0.2, negative 0.5, and then negative 1.5 and negative 4.5. So basically what happens is when I plot these, negative 2, negative 0.1, 0.2, half, 1.5, and then 1, 2, 3, 4.5. And so I end up getting it like a flipped over graph of what I had before. So there's my graph, again, not crossing the x-axis. Just like that. There's my horizontal asymptote on my graph that it'll never cross. Okay? The next two are, again, the same exact thing. So with these, I'm going to show you how to plug these in just to make sure we're doing our parentheses right. So when I plug this one in, let's see. I go parentheses, 2 divided by 3, close my parentheses, and then go caret to the x power. Again, both of the calculators, it should be the same, and so here's what I end up getting. And so on my table, again, I'm still using negative 2, negative 1, 0, 1, and 2. Negative 2, I get 2.25. Negative 1, I get 1.5. 0, I get 1. 1, I get 0.6 repeating, so I'm going to round it to 0.7. And 2, I get 0.3. Again, I'm rounding those. You can add more points on your graph if you want, but you don't have to. So when I do this, negative 2, 2.25. Negative 1, 1.5. 0, 1. 1.7. 2. Oops, I put it on a wrong number here. Whoopsie. That is actually that's 0.4 repeating, so that's 0.4. Whoops, my fault. And then 0.4 right about there. Again, if I wanted to add points, I could add a bunch of points actually. Negative 3, positive 3.3, negative 4, 5.1, negative 5, 7.6, which would get me past my graph. So again, I should get something kind of looking like a half pipe. Like that. Again, never crossing the x-axis. There's my horizontal asymptote right there. On the other one, it's going to be the same thing. Again, just flipping the negative on each of my y values. So I go -2, -1, 0, 1, and 2. I've got -2.25, -1.5, -1, -0.7, and -0.4. So again, I'm left 2 and then I'm down 2.25. There we go. So same thing here. Still have my horizontal asymptote, my x-axis, and it's just going to kind of bend once I get there. There's my horizontal asymptote. There we go. So that's all the graphs are, is just graphing, making sure it doesn't cross the x-axis. You can put as many points on there as you want, but we're always going to kind of center our graphs around -2 through +2 for our x values.